Hello everyone, this is Dr. V.V.Kamesh, Professor of Mechanical Engineering, Aditya University, Surampalem. In this lecture, we would like to discuss about the types of kinematic pairs. So, we know very well what is a kinematic pair. What is kinematic pair actually? When the motion of any two links joined in such a way that the relative motion is either successfully constrained or completely constrained. That means definitely a kinematic pair means two links are to be there, right? Whatever may be the shape of the link, it is a material. One may be circular, other may be linear or translational, something, okay. So, forget about the shape. So, one link is there, second link is there. We need to have the relative motion between these two pairs, these two elements. You call it as a pair, right? Now, we are having only two things. One is completely constrained. The configuration by its own configuration, constrained motion is perfect. Perfect means only in one direction. Suppose if you are having incompletely constrained external application, by means of the external application, if you are making it as happen, it is called successfully constrained, okay. Now, we can see the classification of kinematic pairs. So, once you have the word classification means there will be so many deciding parameters. According to the type of relative motion between the elements. So, one is the relative motion between them, it is the parameter by which we will classify kinematic pairs, okay. So, the first one is sliding pair, right. Sliding pair, this one you can call another name prismatic pair. So, somebody will write with this name, somebody will write with the prismatic pair name, right. Now, you identify the definition. When the two elements of a pair are connected in such a way that one can only slide relative to the other. So, you identify this one can only slide relative to the other. The pair is known as sliding pair, right. Just you observe this, the same example we identified a square hole, right. Suppose this is the body and here I am having a square hole and I am putting a square bar. This square bar is fed inside like this and I am moving inside. It is a completely constrained motion, example we discussed already, right. Now, you see this, even though it is a completely constrained, that is okay. And what is the action between these two? One can only slide relative to the other. That means, if this is the B and this is the A, so this is B and this is the bar is A. So, the piston and the cylinder, crosshead and the guides of a reciprocating steam engine, ram and its guides in a shaper, tailstock on a lathe bed, all will move only in one direction like this and they are all, what is the action? Sliding. So, you can make only sliding, right. And the best normal example in our daily life we can see, we are having the key, right. We are having the lock, we are having the key, right. And how we are making key to be open, lock to be opened? We are putting the key in a straight way inside, that is only sliding. And after that, after reaching the end, then we are rotating, right. So, what is that guiding factor? So, we are having some groove, in that groove we are putting the lock inside and we are making rotation, right. So, what is the first phase? It is only sliding. Now, you can make the lock is part B. Now, whatever the key you have or I have, right, it is the part A. Now, what is the relative motion between the key link and the lock link? It is only sliding, right. That is why it is called prismatic pair or sliding pair. So, this is one variety. Turning pair. Turning pair means slightly different. When the two elements of a pair are connected in such a way that one can only turn or revolve about a fixed axis of another link, the pair is known as turning pair. Okay. Now, you can see actually in this diagram I am having two moments here, right. So, this is the some wooden bar is there or metal bar is there. metal box is there. So in this I am having a circular hole is drilled, right. Let us take this example. So the bar is like this and I am having a circular hole is drilled along the axis, right. Now if I put one circular shaft or something, right. So this is the part B, this is the part A and this is part B, okay. Now I can place this particular shaft inside this, I can place this inside, and how many movements I can have? 2 movements. One is along the axis I can move and I can rotate inside. Suppose the linear motion is prevented by putting some collars here, okay. Suppose I am putting some collars on the shaft. So the shaft cannot move in and around, so linear movement is cancelled. I am having only rotation. Then these two are called forming a turning pair, okay. Suppose I am having another thing. So this is one link, link number 1, and here I am having another link. So this is link 2, okay. They are forming one pair, okay. Just like this, my hand is one pair, my hand is one link and this pen is another link. I am making a joint by putting some pin inside, okay. So here whatever you are seeing in the diagram, I can put a pin. So I can make it a pin jointed pair. Now by joining this, if I am holding the link 1 as a fixed one, I can rotate the link 2, right. So like this I am having turning pairs or rotating pairs. Third one is spherical pair. When the two elements of a pair are connected in such a way that one element, that is especially the spherical shape, turns or swivels about the other fixed element, the pair formed is called a spherical pair. Already we are having so many live examples. One is our human body. This is the hip joint, everybody know it, the hip joint. We are having a spherical pair, right. So this is in a spherical shape, right, and ball and socket joint. So you can see this is the ball and socket joint, and attachment of a car mirror, right, and pen stand, and we are having another word everybody know, joystick, okay. So you are moving like this, okay. So this is ball and socket joint is best example, pen stand, attachment of a car mirror, or the human hip joint. All these are spherical pairs, right. So what is the advantage of the spherical pair? The moment you are holding a spherical pair, this particular link, okay, it can have very high degree of freedom. It can rotate in many directions, right. So the moment of this will be very high, okay. Now what is the degree of freedom? We will discuss later, right. Now the next one is according to the relative motion between the elements is such a way that one rolls over the another fixed link. The pair is known as a rolling pair. We are having only rolling, right. So the ball and roller bearings you might have seen in the right side top. So this is the rolling pair, okay. So one rolls over the another. So the best example everybody know it, the bolt and nut arrangement, the lead screw of a lathe with the nut, or in our daily life we are seeing the integral parts of a pen, right. If you are having a pen with variety, with some screwing and unscrewing, right. With unscrew you open it and change the refill and again you put it fastened. How it is being done? There are some threads, right. So for one part internal threads will be cut, for other part, other mating part, we are having external threads. By means of the both we are putting the refill and we are closing that, okay. So there also you are having screw pair, okay. But here you see in the industrial case, the lead screw of a lathe with the nut. So here we are discussing about the linear moment. Okay, link number 1, link number 2. Two links are there. One link is moving over the another link. Suppose the link 1 is fixed one. The link 2 is moving over the link 1. Right? How it is moving? By means of a screw. If it is by means of a screw, it is called screw pair. If it is by means of the virtue of the motion, then it will be converted to sliding pair. Suppose just you remember, you visualize one situation. Suppose the threads are worn out, right? So due to the wear and tear, the threads are not up to the mark. Then you can move the nut with your hand without any rotation directly from left hand to the right hand of the nut. Okay. So what about the pair? It becomes a screw pair. Screw pair becomes sliding pair, right? Okay. Now you are having the second classification according to the type of contact between the elements. Earlier it is the relative motion between them, right? Now it is the type of contact between the elements. So here we are having only two varieties. One is lower pair and higher pair. So don't think that the lower pair is the least one and the higher pair is the best one, right? Just to have only the classification, we are having two dialogues. One is lower pair, second one is higher pair, right? When the two elements of a pair have a surface contact, when the relative motion takes place, the surface of the one element slides over the surface of the other. Then the pair is called as a lower pair. So where I can have the lower pairs. So it is in all sliding pairs, turning pairs, screw pairs. That means one link surface is having contact with other link surface, right? Just okay, we will see one thing. Okay, I will create this one. Okay, suppose this is one block, metal or wooden, okay, whatever it might be. Okay, now you can see this. So inside this I am having some gap. Suppose I am making some other external part like this, right, with the same contour as I removed in this part A. This is part B. Okay, now I want to make this part B to be fastened with the B and A. Okay, now what I need to do? I need to place this B. Okay, I will show you now how I need to do it. Okay, now the B is to be moved over the surface of the A such that this particular contour is to mate with this. Okay, then what is the final assembly? The B will move over the A and the final assembly will be like this. So I need to move like this. Okay, this is the A and I need to put the left hand and I need to move over this. Then there will be interlocking between the surface of A in this area, the surface of B in the lower area. Now who is in contact with each other? Surface of A and B. That's why it is called as a lower pair, right? The same case with your piston and the cylinder. The cylinder is there, the piston is there and the piston external surface. Okay, it may be with the piston rings, no matter. Let it be piston doesn't have the rings, right? So the complete piston will move around in the cylinder, right? So there will be contact to the piston external surface and a cylinder inner surface. So always you are having the word surface. So it is a lower pair. That means whenever I am having the two links, link 1 and link 2, the contact will be for link 1 surface and link 2, right? Then it is called as a lower pair, right? Now you are having the second one. What is the next one? Higher pair. When the two elements of a pair have a line or point contact, when the relative motion takes place and the motion between the two elements is partly turning and partly sliding, then the pair is called higher pair. Okay. So initially we may not have a direct idea of what is line contact and what is point contact. Okay. So wherever you have the line or point contact, that means you observe the thing, a pair of friction discs. Okay. Okay, let it be initially I will take 2 discs. So this is the disc number 1, this is the disc number 2. Okay. So these, okay, let it be, I am having, my left hand is having 1 disc, right hand is second disc. Now they will be in contact with each other, right. Now if I rotate the disc number 1, forget about the rotation of the disc 2, I do not give any energy to disc number 2, right. Disc number 2 will be along the shaft, it is ready to rotate, but I will give the energy to only disc number 1. The disc number 1 is rotating with some 200 or 2000 RPM, right. Disc 2 automatically, due to the friction in between the disc 1 and disc 2, it starts rotating, right. Now this is actually the origin of the gate trains, right, we will discuss later. Now what is the discussion here? Here the disc number 1, here this is the disc number 2. Now you go to the 3-dimensional view of this, this is actually disc number 1, okay. So like this, okay, this is the disc number 1, right, and this will be the disc number 2, okay. Suppose that this is disc number 2. When these 2 surfaces are in contact, automatically disc 1 and disc 2, they will be in contact with each other, right. Now at a point of time, remember, then what is the contact area or surface or line or point, right, between D1 and D2, it is having a line contact, okay. So this is one disc and this is another disc, so they will be in contact with each other. So disc number 2 elements, disc number 1 elements, right, they will be in contact with each other, the points, and they will be in a straight line, right. That is why it is having line contact, okay. And you can see in the right hand side, I am having rack and pinion arrangement here, that is called toothed gearing, belt and rope drives, ball and roller bearings, cam and follower, all these are will have either the line contact or point contact, right. Okay. Remember one thing, just you can see this pen, right. Suppose this pen is the follower, okay, the pen is a follower, okay, right. Now what is the tip of the pen? It is a point. Suppose this is the different contour, okay. Suppose I am moving this pen over this my hand like this. Now you can see the shape of my bottom surface, the hand, it is irregular, right. So this is having point contact, clear. So if this is the cam, if this is the follower, it is moving up and down, right. Now what is the area, the contacting between these 2 surfaces? This is the link number 1, this is link number 2. Now what is the contact between these 2 links? Only a single point, right. So that is why sometimes you may have the line contact. So this is a line contact or point contact, right. So sometimes you may have line contact in the cam and follower, sometimes cam and follower may have line contact or point contact, right. Suppose the cam is okay, if the follower is a pointed one, then you are having only point contact. Suppose the follower is a roller follower, then it is having line contact. So in both the cases it is called higher pair, okay. Next, the third parameter for the classification of the kinematic pairs is the type of closure, right. So here you are having self-closed pair, force-closed pair, right. When, what is the first one? When the two elements of a pair are connected together mechanically in such a way that only required kind of relative motion occurs, it is called self-closed pair. So, lower pairs are self-closed. In one way or the other, here you identify the word required kind of relative motion occurs. What is that required kind of relative motion? The language is just remembering us desired motion of the link or pair, right? When you heard about the desired motion of the pair as you desire, it is in constrained motion. I think we know very well what is constrained, what is successfully constrained and other things, right? So, the desired motion of the pair according to your need, it should be rotated or it should be having only translation, right? And all the lower pairs are self-closed, right? Now, you are having the second variety, that is force-closed. When the two elements of a pair are not connected mechanically, identify this one carefully, but are kept in contact by the action of the external forces, the pair is said to be a force-closed pair, right? So, cam and follower, they kept in contact by the force exerted by the spring and gravity. You can look at the right side. So, this is actually the cam and this is actually follower. There is no direct mechanical contact between the cam and the follower, right? So, cam will rotate like this and the follower will have touch, right? Why the touch is being maintained between the cam and the follower? By means of an external spring pressure, right? And due to the gravity, okay? So, due to the gravity, the follower will be like this, right? And due to the movement of your cam, it has to move up and, okay? So, this is the force exerted by the spring and the gravity. We are making forcefully the relation between the cam and follower, or in other words, the relation between link 1 and link 2. So, self-closed pair and force-closed pair, two varieties. Now, as a summary, at the end of this, a student can explain the types of kinematic pairs based on the relative motion between them, the type of surface contact or line contact, so the type of contact, and the third one is the type of closure. Thank you.